Hi and welcome to today's video where we are going to continue our journey through algebra and we're going to be looking at something more specific. We're going to be looking at graphing algebra, and you can see here that I've got a couple of algebraic expressions. I got a couple of table of values charts, and I have a Cartesian plane going through the middle of everything. We're going to need all of this in order to graph linear algebra. So why do we need all of these things? Well, it's kind of important. You might remember from a previous video how we were trying to find pattern rules. And if you go back on YouTube and you find pattern rules, you're going to see that we used table of values when we were trying to solve for pattern rules. So that's going to play into what we're doing. Let's get started and take a look at what we're doing here. So we're going to start 2n minus 2 to start. Now, why do we need a table of values? Well, the reason we need a table of values is because the t and the v are actually going to be your x and y coordinates. You'll know that anytime that we are using a Cartesian plane, we have to go along an x-axis and then go up a y-axis or down a y-axis in order to be able to plot specific points. So let's keep that in mind, that when we're using a Cartesian plane, we are always going to be reading x comma y. I'll keep that there just as a visual reminder. So this table of values, you can see here that it is blank. There's nothing written on it whatsoever, and this is kind of the fun part. You, as the solver of the math problem, get to decide what the term numbers are. And those term numbers are going to matter on our x-axis. And why is that? Well, because if you think of this as ordered pairs where you've got x comma y, well, essentially on a table of values chart, your t becomes the x value and the y becomes the value of what the math that you created with. Now that might not make a lot of sense right now, but it will in a second, I promise. So what I generally tell my guys to do in my class is that I like them to choose a couple of negative term numbers to start and then pick a couple of positive term numbers to start. Now you can see here that I only have a range of 1 to 6 on the positive side, a 0, and then -1 to -6 on the other side. So I want to keep my x-axis within that range. So I'm going to start by putting -2 down, and I'm just randomly picking whatever I want the x value to be. So I'll do -2, I'll do -1, and then I'll do, let's say, 2 and let's say 3. Now, why does this matter? This means that on the x-axis, I'm going to actually be using this number to move on the x-axis. This becomes my x. Now, the y is a little bit more difficult to figure out because you actually have to use this number inside of n. So I'm going to plug -2 into here and actually have to do some math. So this is how this would work. I'm just going to put it down here for a second. I will go 2n minus 2, and then I'll plug in 2 bracket -2 to show this term number being plugged into n, and then I'm going to subtract 2 from it. Well, a positive times a negative is always a negative, so that's going to be -4 minus 2, and then I have -4 minus 2 gives me -6. That is how you're solving for the value. So the negative second term has a value of -6. And now here's where it looks like an ordered pair. I'm going to reference this guy again. If I put a bracket around here and put a comma down the line, I now have an x and a y coordinate to use. And all I had to do was plug my term number into here, do the math, and figure out the value. So let's plot this point. It says that I am traveling on my x-axis -2. So I will start at 0, and I will go -2, which is 2 to the left, 1, 2. And then I will end up at -6. So I'm going to go down, because if you look at my graph, -6's are down. So I'm over at -2, and I'm down 1, 2, 3, 4, 5, and I'm down at -6. Now it's really important to not forget to label what your coordinate is. And there's a reason that I want to label them is because when I'm comparing these numbers, if I'm not using different colors, I'll be able to see where the numbers came from. So I'm going to just really quickly figure out what the rest of these values are and start plotting points before I move into the pink. So if I follow the same math again, and I know I'm going to be off the screen while I'm solving the math, I've got 2n minus 2. I'm going to plug negative 1 into n now. 2 times negative 1 minus 2. 2 times negative 1 is negative 2 minus 2. That equals negative 4. So my second value is negative 4. I'll make that into an x and y coordinate with a comma in the middle. I'm going to move over 1, down 4, and I am right about there. Now, if this was a properly measured Cartesian plane, it's going to be important. We are doing linear algebra, which means that I am going to have a straight line if everything was plotted exactly the way that it was supposed to. So let me continue going on the math here. I'm going to go 2n minus 2, 2 times 2, my third term is 2, so I'm going to plug a 2 in. Minus 2, 2 times 2 is 4, minus 2, the answer is 2, so I have 2 comma 2 over 2, this is a positive 2 now, over 2 up 2, and there's my value. Forgot to label this one, negative 1, negative 4, this one becomes 2 comma 2, and then I have my last one, which I'll do up here, 2n minus 2, 2 times 3 minus 2. 2 times 3 is 6 minus 2, a value of 4. So over 3 up 4, always remembering to go x-axis first and then y if I need to, and this will be 3 comma 4. And now I'm going to take a straight edge ruler, and you're going to notice if this was done properly, this should be a straight line. A straight line that goes all the way through, and you'll notice that this one needs to be shifted over a little bit, but it's kind of close here. Now, one of the things that I see as a common mistake is that often kids will just connect the dots. And if they were just connecting the dots, that's a bit of a problem. What we want to do is we want to extend our line all the way out on the graph, and there's a reason for that. So the reason is, if I wanted to know what the value of, let's say, the fourth term was, rather than actually doing the math here, I can just slide over to the fourth term and then see where it meets the line. So if I followed this all the way over to the fourth term and up, I can see that it's going to touch the line about there. So I know the value of my fourth term, 1, 2, 3, 4, term 4, would have to be close to 6 if this was completely accurate. So that is, and the same thing if I went on a negative. If I want to go the negative 1, I could go down until, oh, there it should be a negative 4. But if I wanted to go over, I could see where any of the other terms might be. Say negative 2, for instance, I could go over negative 2 and down until it touched the line. And then once it touches the line, I know what the value is. So I have solved for my green line, which is 2n minus 2. And I'm going to do the same just to compare this line, or this algebraic expression, to this algebraic expression. Now, this concept is exactly the same. I'm just going to switch colors to pink. And what you're going to do is, again, just pick random term numbers. It doesn't necessarily have to be these term numbers here. I can do any term number that I want. So I'm going to, let's say, pick negative 3. I'm going to pick, let's say, negative 1 again. I'll pick a 0, and then I'll do a 1. So you can see that some of my term numbers have matched up and some of them haven't, and that's okay. You are getting to pick which these term numbers are because you're plugging those numbers into the actual algebraic expression. So again, now that we have these term numbers, let's remember that t is x and v is y, and now we have to try to solve them. So let's do that. So negative 3 times the term number, the first term that I have is negative 3. So that's going to be negative 3n plus 4. Negative 3 times negative 3 plus 4. Negative times a negative is always a positive. So that would be 3 times 3 is 9 plus 4. That gives me a value of 13. So I know that it is 13 here, but the problem is that I don't have a 13. So my term number didn't necessarily work out the way I wanted it to. But that is okay because I still have other term numbers that I can work with. So sometimes that's going to happen, particularly if you're working with a smaller Cartesian plane. So let's do some more here. Let's take a look at 3 times negative 1 plus 4. 3 times negative 1, positive times a negative is, oh, sorry, it's negative 3. Negative 3 times negative 1 would be a positive, so that would be 3 plus 4, and I end up with 7. Okay, well, once again, I'm off the Cartesian plane, so I know that that one's not going to work as well. Let's try 0 and see if that works. We're going to go 3 times 0 plus 4. 3 times 0 is 3 plus, sorry, negative 3 times 0. I keep forgetting that it is a negative number. Negative 3 times 0, negative 3, sorry, that would be a 0, plus 4. 0 plus 4 is 4, and now I've got one that works. So I've got a 4, so I'm going to go over 0, and then I'm going to go up 4. So I'm right here on the dot, 0, 4. And now let's take a look and see what happens if I do 1. So let's do it right here. 3, negative 3 times n plus 4, negative 3 times 1 plus 4, negative 3 plus 4 would give me positive 1. So I'm going to go over 1, up 1. And I'm going to end up right here, 1, 1. Now, I only have 2 dots, so that means that I'm probably going to need to do an additional term, because I don't just want to connect these 2 dots. I don't really know whereabouts that line is going to continue on. So let's do an additional one. Let's do term number 2. Let's go negative 3 times 2 plus 4. Negative times a positive is a negative, so that is negative 6 plus 4. Negative 6 plus 4 is negative 2. So I know that my second term number is going to go down 2, over 2, down 2, right there. So 2, negative 2. And now I have 3 dots that I can use, and that makes it easier for me to actually plot my line on here. And you can see that one of these lines, if this was done correctly, is going to travel in a negative fashion, and the other line is going to travel in a positive or an ascending fashion. So you can see that pink is going down, green is going up, and essentially this is it for plotting algebra, linear algebra, on a graph. So once again, we will recap. Always remembering that a Cartesian plane is going to go x-y axis. You're going to get your x from picking term numbers that you just get to pick, and then once you've picked those term numbers, you're going to plug them into the expression to determine what the value is. So in this case, if we had a negative 3, we know that if we did all of the math, we are going to end up with a value of 13. On a regular Cartesian plane, you would simply move over negative 3 up to 13, and your dot would be somewhere up here. The table of values charts, you have an x and y axis. You're simply doing the math, and all of your lines for this are going to be straight. Just don't forget that they're going to be straight. So that is graphing algebra using table of values and pattern rules. If you want to rewatch this video, by all means, go ahead, pause, and stop as you need to. If you see anything that you need clarification on, please leave a comment below, and thank you for watching.